Ever looked at a solar panel and wondered, how does this thing turn sunlight into electricity? It sounds almost like magic. Light hits a panel, and somehow your fan, TV, or phone starts working. In this video, we're going to break it down in the simplest way possible. Let's start with the solar panel itself. From the outside, it looks like a flat, shiny board sitting on a roof. Pretty simple, right? But inside that panel, something very clever is happening every second the sun is shining. Solar panels are designed to capture energy from sunlight and turn it into usable electricity for homes and buildings. That means the sunlight hitting your roof can help power your everyday life. Your lights, your charger, even your fridge can benefit from it. So the big question is, how does the panel actually do that? It all begins with sunlight. Sunlight carries tiny packets of energy, and when those packets hit the surface of a solar panel, they bring in power from the sun. The panel doesn't just absorb heat, it reacts to the light itself. And that's where the real science begins. A solar panel is made up of many smaller pieces called solar cells. You can think of these cells as tiny workers, all doing the same job together. Each one helps capture sunlight and convert it into electrical energy. So the panel is really a team of many little energy-making units. Now here comes an important word: photons. Photons are tiny bits of light energy that come from the sun. When sunlight reaches a solar panel, those photons crash into the surface of the solar cells. And that collision is what starts the electricity-making process. Inside each solar cell is a material called silicon. Silicon is special because it reacts in a very useful way when sunlight hits it. It contains tiny particles called electrons. And normally, those electrons are sitting quietly inside the material. When photons from sunlight hit the silicon, they transfer energy to the electrons. That energy is enough to knock some electrons loose. In other words, the electrons get excited and break free. And once electrons start moving, that's where electricity begins. Electricity is basically the movement of electrons. So when lots of electrons start flowing in the same direction, you get an electric current. The solar cell is designed to guide that movement and push the electrons along a path. That flow is the electrical energy we want. At this stage, the electricity coming from the solar panel is called direct current, or DC electricity. That means the electricity flows in one direction. Solar panels naturally produce DC power as the electrons move through the system. So yes, the panel is now officially generating electricity. But there's one small problem. Most homes don't use DC electricity directly for normal appliances. Things like TVs, air conditioners, and many household devices usually run on a different type of electricity. So before solar power can be used in the home, it needs one more important step. That step is done by a device called an inverter. The inverter takes the DC electricity from the solar panels and converts it into AC electricity. AC stands for alternating current, and that's the type of electricity most homes use. So the inverter acts like a translator between the solar panel and your house. Once the inverter has converted the electricity, the power can flow into your home. That's when it can start running your lights, charging your phone, or powering your appliances. At this point, sunlight has officially become useful home electricity, and all of it started with tiny particles of light. So during the day, if the sun is shining and your panels are working, your home can use that solar electricity in real time. That means while you're charging your phone, watching TV, or working on your laptop, some or all of that power could be coming straight from the sun. Pretty amazing when you think about it. Your roof is quietly helping to run your life. But what happens at night when there's no sunlight? Great question. Solar panels need sunlight to actively generate electricity. So after sunset, they stop producing power. That means homes need another plan for nighttime use. One option is battery storage. During the day, extra solar electricity can be stored in a battery instead of being wasted. Then later, at night or during cloudy periods, that stored power can be used when the panels aren't producing enough. It's like saving sunshine for later. Another option is sending extra electricity back to the power grid. If your solar system makes more electricity than your home needs, that extra energy can sometimes be exported instead of thrown away. Then, when you need power later, you may draw electricity back from the grid. So solar can work together with the larger electricity system. For many people, solar can also help reduce electricity bills over time. If your home produces some of its own power, you may need to buy less from the grid. Of course, savings depend on your system, your sunlight, and your location. But the basic idea is simple. More self-made electricity can mean lower energy costs. So let's recap the whole story. Sunlight hits the solar panel. Photons energize electrons inside silicon. Those moving electrons create electricity, and an inverter converts it into power your home can use. That's the secret of solar panels, turning sunlight into everyday electricity. And once you understand it, it feels a lot less like magic and a lot more like brilliant science.